Hello friends, welcome back to TechScripted. Today I'm excited to show you the integration that I had done. Let me show you how I had done this. So now let's come to the circuit breaker pattern here. So let me show you a diagram explaining how I implemented this circuit breaker pattern. If I have to tell you what exactly it is, so you can think of it as a circuit breaker in your house where when there is a problem, it cuts the circuit to prevent damage. So here, how it is preventing in our case the damage part. Let me show you how I'm protecting my system here, in which after my 5 consecutive failures, the circuit opens and all requests fail immediately for 30 seconds, no waiting for timeouts. And after 30 seconds, it enters half open state to test if the service has recovered or not. If the service has recovered successfully, then it closes. If not, it opens again. Here, what does closes means is if it closes, then it is able to take the request and user is able to make request and it's fine. Yeah. So let me demonstrate this protection in action, how I had implemented in my case. I'm showing you my API. I am testing the circuit breaker and showing you the state. So coming back to my APIs. So here I'm testing the circuit breaker pattern with my JSON. So let's try this circuit breaker in the Swagger. Here I'm providing this as a JSON with the number of requests 10, simulate failure true, and failure count 6. 6 means after 5 it will trigger, and delay between the request is 100. So let's execute this request. Like I had passed 6 there. What does that mean is that normal is closed, the circuit breaker state is closed by normal. So when the failure threshold exceeds 5 failure, it opens. It opens means it is blocked now. It is not success, it is counted as failure. Failure means blockage, that means open circuit. And in case of success, it is giving the timeout of 30 seconds. And half open test, we can then it is the timeout for 30 seconds is for half open request. So, and when it is blocked, then also the half open test is coming. Then if the half open test fails, then it enters into the why I have chosen the Redis over the simple in-memory cache, because of the distributed nature. Like in the case of in-memory cache, it dies when my application restarts, but the Redis persists across the restart, and I can share it between my multiple instances of the application. And in case of microservice architecture, or when I need scaling horizontally, it is crucial. So coming to the data structures, so Redis isn't just a key value storage. It supports strings, lists, sets, sorted lists, hashes, streams, and so like for simple caching, what I'm using the strings here. And in case I need to store as a list, that I may require when I'm queuing the AI requests. Okay, so when I'm using more of semantic kernel functionality, yeah. And in case of sorted list, I required when I have leaderboards or priority queues. So in that case, I'll be using the storage as sorted sets, and I can use it as hashes for storing the complex objects. And when in case of event sourcing, this is the streams which I'll be storing it as using the Redis. And in memory management here, Redis uses sophisticated eviction policies like LRU, LFU, volatile TTL. Like LRU means least recently used, so which removes the oldest accessed items. And in case of LFU, which stands for least frequently used, which removes the least accessed items. And in case of volatile TTL, that removes the item closest to the expiration. And when it's come to random, for when we don't care about the patterns, and we can use that random policy. Yeah. So in my case, in the generate cache, in this method generate cache key, So here I'm using it, like you can see this method using SHA-256 hash data, and before that it is serializing my request and then returning me the hashed for my AI use, and that won't be used with any other controller except for AI. And this ensures deterministic, that same input always generate the same key, and this is collision free because I had shown you the SHA-256 prevent different type of inputs from generating the same key. And in case of namespace isolation, the AI prefix which is returning here prevents conflict with the other cache usage. And operation segregation in terms of different operations don't interfere with each other. And so if you ask me, like cache invalidation strategy, the two hardest things in the computer science are cache invalidation and naming things. So here the way I found to handle that is time based, like TTL, or automatic expiration after 1 hour. And in case of event based, when the AI model updates, then it invalidates all the caches. And in case of manual, admin endpoints to clear the specific cache which can be used. Yeah, the global rate limit for all users, like it is 1,000 requests per minute total, passes on to then the user rate limit, which is set as 100 requests per minute per user. Okay, so keep note of this thing, it is not for all users. So this I'm passing it to the AI endpoint, which is their AI rate limit. Here 20 requests per minute for AI. Okay, so this is my rate limit. So if it passes, the process request goes through. So this is how it works. So rate limiting serves two purposes. One is to protect my system from abuse. Another thing is to ensure I don't exceed AI provider limits. So I had implemented multi-level rate limiting here to ensure the global limits for overall system protection, and my per usage limit for my fair usage, and my endpoint specific limit for expensive operations that I made in case. So when limits are exceeded, the API returns 4 to 9. So too many requests, that means with too many requests with the retry information. Yeah. Now if I have to explain you the algorithm behind the rate limiting, let me explain it. So one is the total bucket algorithm. So imagine a bucket that holds tokens. Each request consumes a token. The bucket refills at a fixed rate. If the bucket is empty, request is rejected. This allows for burst traffic while maintaining the average rate limits. So fixed window counters, how it is like? It is like counts request in a fixed time window, like every minute. Simple, but can allow double the rate at window boundaries. So another thing is the sliding window log, so which maintains the log request timestamps, more accurate, but that is memory intensive. I calculated the request in the past some seconds for every new request. So in my implementation, I am using ASP.NET Core rate limiting middleware, which implements sliding window algorithm. Okay, the best balance between the accuracy and performance. Yeah, I can show you the rate limit test with the multiple requests. So here the retry policy comes into the picture with Poly, the resilience framework, which what you call. So here I'm showing you the architecture and the way this works, how the Poly works. So let's now talk about the Poly, the .NET resilience framework that makes my AI integration bulletproof. So Poly is like having a smart assistant that handles all the way external services can fail. Now, why Poly? Instead of writing complex try-catch blocks everywhere, Poly provides elegant configurable policies for handling failures. It's the difference between amateur error handling and enterprise grade resilience. Here is what I have implemented with Poly, and you can see here my wait and retry async method, which I am just showing you now. So as you can see in my this async policy here, so this creates a delay of 2 seconds, as you can see here, right? This math.pow 2 seconds and then retry attempt. How it is working is this creates a delay of 2 seconds, 4 seconds, 8 seconds between retries. Now, why exponential? Because if a service is struggling, hammering it with immediate retries make things worse. Yeah. So exponential backoff gives the service time to recover. And now the circuit breaker integration with polys, like a poly circuit breaker is more sophisticated than the basic implementation. So either you have two ways now. The one which I had implemented is integrating the circuit breaker with the poly, so it is more sophisticated. It tracks success failure ratios over time and make intelligent decisions when to open the circuit. So I can show you the timeout async, the magic policy wrapping here with this resilience policy here. So policies execute from right to left. Make sure. So this is what I want you to notice is policies execute from right to left. Timeout wraps the call. Circuit breaker wraps that. Retry wraps the circuit breaker, and fallbacks wrap everything. And it's like layers of protection. Yeah. So here in this diagram, I can show you the poly retry pattern with jitter. So without jitter, this is the way, like jitter is a crucial at scale. Imagine 1,000 clients all hitting a failed service. Without jitter, they all try exactly 2 seconds, creating a thunder herd that can crash the recovering service. Jitter spreads out the retries, giving the service a chance to recover gradually. Poly also provides hedging strategies like sending multiple requests in parallel and taking the first successful response. That is perfect for read operations where latency matters more than the cost. Now here comes the semantic kernel integration part. So I'm showing you a diagram which is architecture for semantic kernel flow, where the user query comes to the planner tasks. So basically, before coming to it, let me tell you that semantic kernel is the Microsoft framework for AI orchestration. It allows me and you to chain multiple AI operations. In my case, I can change multiple AI operations. So using this semantic kernel, I had chained multiple AI operations. I'm able to now reuse the prompt templates and add memory and context and plan complex multi-steps operations. So I have integrated it to enable the advanced scenarios like summarize this document, extract key points, and translate to Spanish all in one operation, right? So let me show you how that is working in my case. So this is my summarize text summary. Yeah, let me try it out. And suppose if I pass explain semantic kernel in a sentence, and okay, now it's running fine. So let me check it out. And let me hit this summarize method once again. Maybe earlier that connection string was commented by my side because I was testing some of the things. Semantic kernel in one sentence in Spanish language. So here it worked. You can see la definition de nucleo cemento something it has written. So this shows. And now I want to once again see this operation. So let me check this test circuit breaker pattern once again to show you the exact. So let me now show you the way I had implemented the other APIs, like I think this one I had shown you already, rate limiters. Yeah. So here you can see in the rate limiter, so how this is attempting the first request, second, with request remaining 60 here, and these are the request 10 request it has made here now. So and this is what I wanted. So this is how I am testing it. So the rate limit exceeded for this user because already I had made the requests like that. So if I again do the same, then so here is the API for to check the compare providers here. Just like that, I'm passing anything. So it is showing me that I'm using the OpenAI. So if I switch on to Azure API AI, then it will show the Azure one. So this is how I'm checking that which one I'm using. And moreover, I want to, yeah, I'll show you my dashboard also. UI is also there for this. So which is currently perfectly fine. So I had implemented health checks also in this, and that also I am going to show you how I had done that. So this how for health monitoring, and what exactly my health dashboard is showing here in the browser. It is showing my healthy database, and so you can see my health dashboard here, which is showing my overall health as healthy. I think now you can see my health dashboard, which is showing me the status as healthy. Yeah, what exactly it covers: my database health, Redis Cache, which is showing as healthy, AI service as healthy, and rate limiters as degraded due to higher usage. Performance metrics: the response time it is showing as 24 milliseconds, and success rate is showing as 99%, 99.8% success rate. Cache hit rate is 87%. The average circuit all closed. So I've implemented comprehensive health monitoring, in which real-time health dashboard I had shown you. My individual service health checks are also there. Performance metrics tracking is in place, and visual status indicators are not showing currently. So now I had shown you provider comparison test, in which there is Azure OpenAI and OpenAI, and the cache performance test, circuit breaker pattern test, rate limiter test. I have thoroughly tested all these components, using the provider testing, cache testing, circuit breaker testing, rate limiting testing, and integration testing, end-to-end scenarios. So all tests are automated, and I can run it through PowerShell also, for which I had made these scripts. I can show you here. You can see. And some more scripts are there for API tests. And one more thing to tell, because I didn't run from the Docker. You can see the application I was running the old way, but not using Docker because already it is consuming a lot of resources, and my hard disk is not having that much space left now, so it will slow down my system too. So that's why I opted for showing you this way. But in case you require, you can use this kind of Docker the way I'm using it, so that once it is deployed in the Docker, so this will be as an image, and it will run from there only, and easily I can start and stop from there. And these are the ports. All dependencies are listed here. Let me show you the real impact of this architecture. Scenario one, in case of customer support chatbot, if I have to customize it for handling that, it handles thousands of similar requests. Yeah, and what more? So in case of scenarios like customer support chatbot, where it handles thousands of similar requests and 87% of cache hit rate, it equals to 87% of cost reduction. That equally means, and instant cache responses for cached queries. And in case scenario 2, where I'm already having this document processing system where circuit breaker prevents the cascade failures, automatic provide failover, rate limiting prevents cost overruns. And another scenario can be where I had multi-tenant SaaS, where per user rate limiting ensures fair usage, health monitoring for SLA compliance, and cost contribution per tenant, right? What I had achieved in this architecture and the way I had implemented this is I had abstracted my API providers. I don't tie my code together to one vendor. So my parallel running is there for Azure, and parallelly I have system in place for OpenAI. Yeah, and aggressively I'm using the cache. All calls are, because I feel like all calls are expensive, I need to handle them in that way. So cost optimization is one of my aim, which I'm getting it fulfilled using this Redis cache, and the way I had done the poly retry. Fail gracefully, for that, as I told you, I'm using the circuit breaker and retries, so that I can handle the fail scenarios gracefully. And monitoring everything, I need more visibility, so I'm having more visibility as per my monitoring system in place. And I am protecting my resources using the rate limit at multiple levels. So here I can show you in my code also. So this architecture has reduced my AI cost by 85% while improving reliability to 99.9 uptime. This is my AI integration system in place. I had built a production ready or close to production ready architecture that is currently supporting multiple AI providers, and reducing my cost through resilient caching, handling failures gracefully, protecting my system abuse, providing me comprehensive monitoring. And this is my enterprise AI integration system in place, which I had built as a production ready architecture. And if not, it is close to the production ready architecture now, and it supports multiple AI providers currently. And I had made it to now reduce the cost through intelligent caching. In place is handling the failures, which I'm gracefully doing it as I shown to you. And I'm also protecting against abuse, providing comprehensive monitoring also at the same time. All my code is not available in the GitHub right now, because I have some other plans. I had shown you the way I implemented. If anybody who is keen interested in getting, let me know. Please drop me in the comments what exactly is required or which module is required. I'll share that. Keep watching my videos. Do subscribe my channel, or if you have something, do send me in the comments. That will be cool, and I'll reply to that. Yeah, see you guys.